Welcome back, all you wonderful algebra students. Today we're going to tackle section 8.6, and this may be a long video, or I might just make it into two a little bit shorter ones. Today's assignment, and most of this is old news. What is going to be a little new is the fact that now we've got variables with higher exponents. But we're going to just distribute here today and collect like terms, but our variables are higher. Let's do a little bit of review here. We understand that when we are asked to multiply two things together with the same base, so here's x squared and x to the third, we add the exponents. X squared times x to the third. Well, what is that? X squared looks like this, xx. And x to the third looks like this, x times x times x. Well, there's 5 of them all together, so that is x to the 5th power. So the shortcut way is simply to add the exponents. And of course, remember, if you don't see an exponent on something, there's a 1 there. So there's a 1 right here. And then, of course, the numbers just get multiplied the way we've always multiplied numbers. So let's take a look at this first one. Let's see what we get. All right, negative 2 times 3. We're just multiplying here. We're not adding any exponents yet. Negative 2 times 3 is a negative 6. X to the second times x to the second. Add the exponents. 2 plus 2. 2 plus 2 is 4. So this is x to the 4th. So we're distributing. There's the first one. Let's do the next one. Negative times negative would be positive. 2 times 2 is 14. X to the second times x. That's to the first. You don't see the 1 there, but it's there. X to the second times x to the first. 2 plus 1 is 3. This is x to the 3. Okay, next one. Negative 2 times 10 is a negative 20. X to the second. Well, there is no x's here, so we're just letting it come along for the ride. All right, so there you go. We've just now distributed, multiplying a polynomial by a monomial. That's pretty much all that you need to do in regard to understanding how to distribute. You're always distributing. We're going to practice now simplifying something with multiple like terms. Okay? All right, let's take a look at this one. You'll notice that we're going to have to distribute this 4 into this polynomial here. And here we're going to have to distribute the thing that's in front of it, which is negative d. So the negative has to get distributed in 2. We did this in the last section as well. So let's start at the left and work our way to the right. Here we go. 4 times 3 is 12. D squared. I'm not going to do anything with the d there. 4 times 5d is 20d. Easy peasy. All right. Now we're going to multiply negative and d times d squared. Well, d to the first, you don't see it, but there's a 1 right here. D to the first times d to the second is d to the third. But I had a negative. This is really a negative 1 you don't see here. So this is a negative 1 d to the third. That's your first term. Next one, negative times negative will be positive. 1 times 7 is 7. And d to the first times d to the first, add the exponents. That would be d to the second. Now the third guy, negative 1d times 12. Well, negative times positive is negative. 1 times 12 is 12, and then the d comes along for the ride. Now double check everything before you move on. Now notice the reason why we had to multiply that in is we can't add anything together when there's a parentheses in the way. They kind of limit us. It's like a barrier, you know. So now we're going to look for monomials here that can be added together, and we're going to look for the highest one first. So here's d to the second, d to the first, d to the third, d to the second, d to the first. We want to pick the highest one, and it's this one. So we're going to take this guy and we're going to bring it over here. Notice I'm circling the sign as well. So the first term is negative d to the third. Okay, now let's look for the next highest, which would be d to the second. Here's one here. And here's another one. Again, notice I'm putting a box around the sign as well. D squareds can be added together. Now when we add, we do not add the exponents. We add exponents when we multiply. But here we got to have like terms, and we add the numbers out front. So 12d squared and 7d squared gives me 19d squared. Okay? And finally, we've got 20d here, positive, and negative 12d. Okay? So they're like terms. So 20 and a negative 12 is 8d. So what you need to try to remember here is when you're multiplying, like up at the first step, you added the exponents. But when you're adding, you have to add like terms, and you do nothing with the exponents. Rewind and listen to that a few times so that makes sense to you. Okay? Well, there you go. It's simplified now because there's no like terms to get together. Let's look at the next one. All right, here's the next one. Now, you notice there's an equation now. So instead of just simplifying this, the instructions are going to say solve. So they should say at the top, solve. That means we're trying to get the variable alone. Now this is a long one, so I had to write pretty small here, but we're gonna work our way through this. And we need to collect some terms and see what we have here. But before we can collect any terms, we've got to distribute and get rid of these parentheses. So I'm going to start at the left here. Remember, a variable that doesn't have an exponent has a 1 there. So y times y, 1 plus 1 is 2, minus 12y plus y squared plus 2y plus 25. Notice I'm just working from left to right. All right. Now we're distributing here. 2y times y is 2y squared. 2y times 5 is 10y minus 15. All right, there you go. Now, the right thing to do here would be to collect like terms on each side. On the right here, I don't have any terms that can be added together. There's a y squared and a y and a 15 negative. But over here, I do have some things that are like terms. For example, there's a y squared and another y squared. Note I'm starting with the highest degree here. Well, what do we do when we add these together? No, it's not y to the 4th because we're adding. And when we add the numbers up front. There's a 1 here and a 1 here. So 1y squared and 1y squared is 2y squared. Take a good look at that. Then we've got y terms. Here's one here, and here's another one here. Notice I'm putting a box around the sign as well. Negative 12y and a positive 2y is a negative 10y. Then all that's left over here is the 25. So let's bring everything else down. All right. Now, we're ready to solve this, and usually we try to start again with the highest degree. This is why you did that assignment on degree. This is highest degree is second degree. Well, just like if we had things with like x to the first power, we can add or subtract something from both sides. In this case, I'm going to take away 2y squared from both sides. And that works out great because both of these are going to go out. 2y squared minus 2y squared is 0y squared. Now I could write this. I could write 0y squared here if I wanted to. But isn't 0 times anything just nothing, 0? So this is 0, and I don't even need to write that. Same thing over here. So I'm not going to write anything. They just go out just like they have in the past when two things are opposites and we add them up. So now we've got negative 10y plus 25 equals 10y minus 15. All right, now we're going to get the variables together first. Okay, I've got y's and y's. Let's add 10y to both sides. I want to try to keep my y variable positive. Well, once again, this is going out as expected. A negative and a positive 10y go out, and I get 25. And this is now 20y. All right, it's looking simpler already. Now we're going to add 15 to both sides, and this is kind of old news for everybody. 25 plus 15 is 40 equals 20y. And again, the negative 15 and the positive 15 go out. and then we divide both sides by 20. So y is 2. So if we took 2 and stuck it back up in here in the problem, it would make the sentence true. So what do you need to know here? Well, first of all, distribute. First thing to do is distribute, then collect like terms. Okay? Then deal with the highest variable first. Highest variable. Okay, then you deal with the other variable, and then you go ahead and solve it the way you've normally done. Okay? Well, that's the basics of this assignment, and you're going to have some odd ones to do tonight, and you can check those answers, and please do in the back of your book. Now, since we've got plenty of time here, I'm going to go ahead and introduce tomorrow's material as well. So let's take a look at that. All right, let's take a look at one of the problems on tomorrow's homework. Let's take a look at 12 through 14. I'm going to do this one with you. So grab your notebook and get your book open there. We're going to take a look at problem 12 to 14. All right, I'm going to read this problem out loud, but you need to follow along in your book. This is on page 446. Pause the video and make sure you're looking at problems 12 to 14. All right, here we go. It says savings. Kenzie's grandmother left her $10,000 for college. Kenzie put some of the money into a savings account earning 4% per year. And with the rest, she buys a certificate of deposit, a CD, earning 7% per year. Question 12. If Kenzie puts X dollars into the savings account, write an expression to represent the amount of the CD. So Kenzie's grandmother gives her $10,000, and some of that money she put into a savings account, and some of that money she put into a CD. What a CD stands for is a certificate of deposit, and what that is the money has to sit in there for a certain period of time for you to earn that interest. That's why the interest rate is higher. Mackenzie would get 7% if she left the money in there for a while in her savings account she only earned 4%. By the way, if you have a savings account, my guess is you're probably only getting about 1%. So Kenzie's getting a pretty good deal here, getting 4%. The CD is paying higher because she had to leave the money in there for a particular period of time, like 6 months or a year or something like that. Now, number 12 says, if Kenzie's put X dollars into her savings account, she put X dollars into her savings account, write an expression to represent the amount in the CD. Well, that means that the CD plus the savings account has to give her $10,000. But if we think backwards, that would have to be $10,000 total and take away the savings account, and that would give me the CD. Isn't that right? So there's the answer for number 12. Number 13. Write an equation now. We're going to use an equation for the total amount of money, T, the total amount of money, T, that Kenzie will have saved for college after 1 year. The total amount of money that Kenzie will have saved for college. Okay? So she left her college, and Kenzie puts some of the money into a savings account per year, and the rest she buys a certificate of deposit. Write an equation for the total amount of money Kenzie will have saved for college after 1 year. Well, let's see now. Kenzie's going to make 4% on her savings account, right? 4% on her savings account, plus she's going to make 7% on her CD, and the CD is this expression that we just came up with. So there is an equation for the total amount of money Kenzie will earn. This is her savings right here, savings, and this is the CD over here. 7% in the CD plus 4% in the savings account. Savings account was X. Now this would be an okay answer, but they want us to simplify it. So I'm gonna do that with you. Let's distribute here. We'll leave this part alone here. And we're going to distribute this number into both of these. Well, 7% of 10,000 is, well, let's see, 10% would be 1,000. So 7% is $700. That's 700. And then in here, 0.07 times X. So I distributed into both of those. 7% of 10,000 is 700. You could use your calculator if you needed to there. Okay. So this is the amount of money that she's earning. So this is really not the total yet. The total is going to be what she earns plus the $10,000 at the beginning. So that's going to be our total. She had $10,000 to begin with. So here's what she earns in savings. This was her initial amount. This is what she started with, initial amount. This was her savings account, and all of this is the CD. So some of the money she was given originally, but she's also earning some interest, and that's wonderful for her. So let's finish simplifying this. 0.04x and minus 0.07x would give us negative 0.03x plus 700 plus that 10,000 that she started with. So if we were to simplify this, we would just add these two together, and I'm running out of room here, but this is 10,700 minus 0.03x. There's your answer at the bottom there. It's a little tight in there, but this is 700 plus 10,000 minus 0.03x. There's a lot of thought involved in this, but you will have another problem that you'll have to do something like that on problems 49 and 50. So you go ahead and kind of keep an eye on this example. You may have to come back to it. If you write it down, and then you can come back to it on 49 and 50 tomorrow. All right, let's look at one more with a picture. All right, here's the geometry problem, and it's the kind of thing you may have done in the past. You're probably going to do it in geometry class when you get to that class. The problem is asking for us to find the area. Okay, now it asks us for the area of the shaded region, and that's what I'm showing with these hash marks here. Well, isn't it true that I'm going to have to take the area of the large rectangle and subtract from that, take out of that area, the area of the small rectangle. And that'll give me the area of the shaded part. Okay? The area of the large rectangle minus the area of the smaller one. Okay? So the large rectangle, well, the area for a rectangle is length times width, isn't it? So the area of this large rectangle, well, the length is 4x, right up here, and the width is 3x plus 2. Notice I'm putting it in parentheses because I have to multiply the entire thing. The whole thing is the width here. Minus the area of the smaller rectangle. Well, I'm going to put this in parentheses just to make sure I get it right. The length times the width. And the reason I put the whole thing in parentheses is I got to subtract all of this, and I wanted to make sure I wasn't going to not do that. So, all right, the area of the large rectangle is here, minus the area of the smaller rectangle, and that ought to give me the shaded region. So here we go. Let's distribute again. 12x squared. Remember, x times x, when we're multiplying, we add the exponents. And this is 8x. Here, I'm going to subtract. This is now 6x squared in here. If I distribute the negative in, I get a negative 6x squared. Don't really have to distribute. It's just applied to the one. So it turns out I really didn't need the parentheses there, but sometimes it's better to put them in and not need them than to need them and forget to put them in. All right, now we want to collect the terms, and we see that there's an x squared term here and another one here. Notice I'm starting with the highest highest degree, 12x squared, and a negative 6x squared. Now we're adding, so don't add the exponents, you're adding the numbers out front. 12 minus 6 is 6. X squared, 12 minus 6 is 6. Plus 8x. And that should be the area of our shaded region. Okay? We'll have another problem like that, number 38, where you're going to have to calculate the area of the shaded region. Now, I think I'm going to stop this assignment here at this point, and you can practice these problems. You've done a lot of this before with distributive property, and I'm going to let you do both assignments, do one a night, and then if you got a question, give me a jingle on the email, and I'll try to set up a way to talk you through it, either with an email or a Zoom. Don't forget that we've got a Zoom meeting on Wednesdays at 11 o'clock each week, so please make sure you're there for that Zoom meeting in case we have any announcements that we need to make. There'll be a Zoom meeting every week at 11 o'clock. I'll be Zooming with you, so you go there and meet with me, okay? Remember, at the end of this chapter, you'll be taking a test, so make sure you keep up every day and don't get behind. Let's take a look at your homework for tonight. All right, here are the assignments for the next 2 nights. Please go back and watch the video if you get puzzled on something, because everything you need is in there. I've been pretty clear about how to do these. The first assignment's number 41. You're doing mostly the odd ones there. And then the next night, you're going to do number 42. We've already done 12 to 14 and number 37. 37, I guess, is on here. So 37 wasn't on the assignment, but what was on this previous assignment here, I guess. So go ahead and tackle these. Give me a buzz if you need something, and I'll see you next time.